Okay. So, in this video we are going to verify the Newton's second law and find out the value of the mass experimentally. So, for this we have an experimental setup, which is the dynamical track, and we have a motion sensor, and we have a cart having a mass 500 grams, which having the 4 weights. We have it, which is 540. So, this will be 540 gram, and this hanger mass is 5 gram with the 5 gram extra mass. So, this is the 5 gram extra mass. So, its total mass will become, it is connected to the pulley in that fashion. So, when this object move, it falls under the action of gravity. So, the situation is just look like this. So, you have a table, and over there is a mass, and it is connected to a pulley with a string, and then this mass is hanging, which is your hanger, and this mass is your mass of the cart. Okay. So, the formula for the acceleration to find the theoretical value is m hanger times g over m hanger plus mg. Okay. So, this is the acceleration theoretically. We can find the acceleration experimentally by using the slope of velocity versus time graph, and we will do it. So, the total moving mass is this 10 gram of hanger and 540 grams of the cart. So, the total mass of this will be 0.550 kilogram, okay, for the first reading. Okay. And then we have a logger pro over there. So, when you open it, so it will give you two options. So, you have a velocity position versus time graph and velocity versus time graph. So, in this experiment we only need the velocity versus time graph. So, we only take the velocity versus time graph. So, position, velocity and time you have all there. Okay. Now, take the first reading. How to take the first reading? So, to get the theoretical value and the experimental value. So, take this for example. Okay. And we bring over here, we start taking reading. Okay, 1, 2, 3. We have a mass on the cart 540 gram, hanger on 10 gram, it should be pulley, and then let's go down. Yeah, okay. So, now we have a reading over there on the logger pro. So, we just select it, auto zoom. So, we take an auto zoom, and then we select a particular region over here to get linear fit. So, linear fit will give us the slope of the object, which is like this is a slope, it is giving. So, this will give you the experimental value, which will be 0.1249 in that case, and the theoretical value can be calculated by this formula m hanger g divided by m hanger plus, and for this m hanger you have this mass. So, you will get the theoretical value, experimental value, and you get all the readings by performing. Just for example, if you wanted to perform another reading, so you take it, okay, and then you store it in the latest run, okay, and then perform another reading like this, and we leave it. Okay. So, this mass has to be there. So, to perform the reading again, so this mass should be constant. Again we are going to perform it. So, 1, 2, 3. Okay. So, see this. So, when you selected this region, so to make it a linear fit on the latest run, so this will give you the slope, which is 0.276. Okay. So, when you get all the readings, so you plot this column and this column over here you will get a straight line. So, f versus a experimental. So, when you take the slope, which is nothing y2 minus y1, x2 minus x1, this will give you the slope experimentally, and theoretical value you have this value. So, you put over here and put e minus t over t, multiply by 100, it will give you the percentage of error. Okay. So, this is how we verify the Newton's second law. Thank you.